Hello and welcome to Chapter 8, Section 2, and we are doing problem number 29. In this problem we are given a graph that models a Ferris wheel's height as a function of its time. We are asked to find a formula for h as a function of time, and they want us to use the sine function to do this. And so this problem is relatively easy. All we really need to do is first we need to identify our a value, which applies the horizontal stretch. We need to find our b value, our a value for the vertical stretch. I'm sorry, that's the vertical stretch. The b for the horizontal. And we need h and k. So in this, we know that a, the vertical compression or stretch, is equal to that of the amplitude. So to find that, first we're given the trough and the max and what appears to be the midline. And if we subtract 35 from 20, we find that this equals 15. If we subtract 5 from 20, then we also find that this distance equals to be 15. So the amplitude is 15 and our midline is 20. So amplitude is equal to 15, so A is equal to 15. And we also found the midline, and the midline will be our vertical shift. So our midline, K, which is K being the vertical shift, will be equal to 20, because it shifts from 0, which is the original midline, where it originally oscillates along the x-axis, but we're shifting that up 20, so now it's going to oscillate around 20 instead. So we have those two values. Next, we need to find b. We know that the period, the time it takes for it to complete one cycle, we start at the top, at the beginning of the cycle, and follow it down, and follow it back up, and we see here that it has completed one full cycle. So we come down, and we find that it took 4 minutes for it to complete that one cycle. So the period is equal to 2 pi divided by the absolute value of b. We just found that our period is equal to 4. So 4 equals 2 pi divided by the absolute value of b. And so multiply b by both sides, it'll cancel, and you'll have 4b, divide 4 by both sides, and you'll get b equals pi over 2. So now we have our b value. And so now we need our h value. How far do we have to shift horizontally this function in order to get it to look like this? Well, remember that we have to use a sine function. And what does a sine curve usually look like? Sine usually would start at the x-axis and go up, and then back down, and then up again. Whereas cosine starts at its max, goes down, and comes up. This looks like a cosine function. So we need to find where would the sine function be and shift it over. Well, we have some values here, 1, 2, 3, and 4 on the t-axis. And so we know that if this were originally a sine curve, it would have come up like this, right? So it would have come up. So we know that it would peak at right here. So this is where it would peak. So we need to shift over this way to the left 1 unit. So h is equal to, let's say, 1 unit shift, 1 unit to the left. So let's go ahead and start writing our formula. H of t is equal to the amplitude was 15 sine, because we have to write this as a sine function, parentheses, and then there was a shift up of 20 units. And so in here we know that b is equal to pi divided by 2. And we can put t in here. And we know that we are going left 1 unit, so we're going to add 1. And so we can go ahead and multiply this out. This is t pi divided by 2 plus pi divided by 2 plus 20. And comparing this with what we get in our homework, let's see, can I get y'all to see this? Yeah, so 20 plus sine pi over 2 t plus pi divided by 2. So that checks. Awesome. I will see you guys in the next video.